Okay, so proof by mathematical induction is a certain steps that you want to follow. Okay, and so this is a series. This is I think it's an arithmetic series. No, actually, it's a geometric series, isn't it? So I'm taking the term and multiplying by 8. Well, I don't know about that now that I say that, but I don't take the last term and multiply by 8. I take the term and multiply by 8. So I don't know if it's probably neither arithmetic or geometric. In fact, it's not. So, but we can we're going to show that this series, whatever kind of series it is, has a sum that's equal to this. And maybe it's not equal to, but since they're telling us to show that it is, it probably is. So there's certain steps you want to follow. So the first step is called the base case. And that's n equals 1 or n equals 0. I've seen it done both ways. I tend to use 1. So the first term is 8. So the first number is 8. So when n equals 1, the series is 8. So let's go over to the other side. And is 4 times 1 plus 4 times 1 squared also equal to 8? Well, that's 4 plus 4. Yep, that's 8. So the base case is true. We can continue. If it were not true, then we can just stop right there and say it's done. So base case. Then you're going to say, okay, well, if it works for 1, let's assume it's going to work for any number. And what we'll do, then we'll say n is k. So what you do is every place you see an n, you substitute in k. And that's the k case. Plus 8k equals 4k plus 4k squared. Same thing, you're just replacing the n's with k's. And now we're going to do the induction step. So this second part isn't important, but it's a pretty easy step. But now we're going to do the induction step. And what the induction step says, okay, we're substitute in k. Now I want to say one more number. So in that case, we're going to replace every place we see a k, we're going to replace it with k plus 1. So, but before we go there, we know it's true for, this is the sum for any k numbers. So what we're going to do is we're going to do the old sum plus one more term equals some new sum. And if you've seen enough of my examples of induction, you see that's exactly what I do. So I know the old sum is 4k plus 4k squared. And now I'm going to do one more term. Well, how we generate the next term, we take it multiply by 8. So 8 times k plus 1. So that's the one more term. Now we have to have it equal to a new sum. So that's going to be 4 times k plus 1, because that's k plus 1 more, right? Plus 4 times k plus 1 squared. Now we've got some algebra to do. And because this is an identity, just like when we did trig identities, we don't want to be moving things across the equal sign. We got to work on each side separately and try to make one look like the other. So I guess what I'm going to do first off is I'm going to work on the left-hand side. So 4k plus 4k squared, and I'm going to distribute that 8 through. And then I'm going to collect like terms, so 4k squared plus 12k plus 8, and I see I can factor out a 4. So k squared plus 3k plus 2, and then I know that quadratic factors to k plus 2 times k plus 1, and I think, let's go take a look over here at this side. Well, let's see. I see that I can factor out a 4, and I can factor out a k plus 1. I mean, I could do some expansion, but why not do a little factoring by grouping? So this is not plus, it's going to be times. Here's my eraser. I'm factoring out a 4k plus 1. So what's left? Well, I factored out a 4k plus 1, so there's a 1 there. That 4 has been factored out, and I only have one k plus, see, it's k plus 1 squared. I factored out one of them, so I just have a k plus 1. And lo and behold, look at that. 4 times k plus 1 times k plus 2. And isn't that equal to this? So done. We've verified that by induction. So base case, the k case, the induction step. Okay, in the induction step, it doesn't hurt anything to write old sum plus one more term equals the new sum to help keep yourself straight. Okay, and that's the process of mathematical induction.